Hey everyone, welcome back to our statistics class notes here in section 9.2, and we're about a fourth of the way down page 142, looking at a new example where we're trying to make sure we continue to dive into understanding the essential limit theorem for sample means. So here I want to do an example I've titled Identify the Distribution. So one of the three distributions below represents a population. So I placed three distributions here. One of them represents a population. The other two distributions are approximate sample distributions of the sample means randomly pulled from the population. One of these is for samples of size 10 and the other is for samples of size 25. Okay, so we're going to match the graphs with the correct distribution. So first of all, one that doesn't look kind of symmetric is this guy. So this has to be the population, because we know that when we pull sample means, we're at least going to get something pretty symmetric. Even if our sample size is too small, like a sample of size 10, it's not quite normal. Looks like maybe a little skewed to the right, but it's still symmetric-y looking. This one is not at all. So that indicates to us that we're talking about the population. Since the essential limit theorem tells us that sampling distribution for sample means is approximately normal, this one could not be a distribution of sample means. Now if I pulled samples of size 10, I'm going to get a larger standard error than for samples of size 25. Remember, it's sigma divided by the square root of n is your standard error. So you're going to have a larger spread here. This one's a little bit tighter, more of the samples clumped in here towards what appears to be the population mean. So this one has to be for samples of size 25, whereas this one has to be for samples of size 10.